In 32, we're asked to write the sinusoidal equation for the following graphs. We've split this up so that in this one we have 32a. Now, I like to look at what we see is the maximum value on our graph and what is the minimum value on our graph. And let's start to collect some of that information here. I take to look at max, at the midline, at the minimum, and at the period. This is all the information that we can decipher from the graph itself. From the information that we get here, we will be able to determine the values A, B, C, and D and use those to write the equation in this form. Y equals A sine B theta minus C plus D. Okay, so let's go back to the graph at hand. And we determined that the maximum was 7, the minimum was 3, the midline, therefore, is at 5. The period of our function, very straightforward here. We have a sine function that starts at 0 and ends up at 2 pi. So our period here is 2 pi. Now remember, our amplitude is the maximum minus the midline, or the midline minus the minimum. It's the difference between the midline and either the max or the min. So our A value here, or our amplitude, is 2. Now our B value is calculated. Remember, 2 pi over B will equal your period. Well, in this case, we saw that the period was 2 pi, or 2 pi over 1. Therefore, B equals 1. Our C value, remember, is the phase shift. That's the shift left or right. And in this case, our sine function is not shifting at all. It starts here at 0 and completes one full cycle at 2 pi. So there's no shift there at all. The vertical shift, and that we know that these graphs without any shift are centered on the line 0. Notice that this one is shifted wherever its new midline is. In this case, the new midline is at 5. So now let's go ahead and let's write this equation, and we would get y equals 2 sine. We don't need to write the 1. We have theta. No need to put in minus 0. We'll conclude our parentheses there, and then we will add 5 for that vertical shift. And that's our final equation.